So when we talk about the actual heart, okay, it doesn't look like your stereotypical heart that you draw. All right, it's got two smaller portions up top and two bigger portions in the bottom. And it's much cruder than this, okay, much cruder than this, but that's how we're going to draw our heart. Now, I'm just going to make this whole thing a little bit smaller, and I'm going to center it. So we're going to talk about the actual body circulation, and we're going to talk about flow of blood through the heart. So this is going to get both the systemic and pulmonary circulations, so those dual circulations because of our divided heart. And it's also going to talk about the flow of blood through the heart. So here we've got 4 chambers. All right, and we're going to start off, just for the sake of this video, and we're going to pick an arbitrary spot. Okay, so coming in, we're going to start with blood coming from the body to the heart. Now that blood is deoxygenated or oxygen poor because it's just been to all the cells in the body and it's given, the red blood cells have given up their oxygen and taken up carbon dioxide. Now they have to get rid of that carbon dioxide. But to do so, we know that if we actually look at the notes, we know that by the time venous blood gets back to the heart, the pressure in that actual vessel is so low that it's almost non-existent. So it has to go back to the heart before it can go to the lungs for gas exchange, so that the heart can pump it so that it gets to the lungs with enough, basically, energy. Okay? So that starts off where blood comes into the actual right side of the heart, which appears on the left side of the image. But if you look down at your own heart, you would see that the actual, what we're talking about is the right side of your own heart. Now, the right side, or the right atrium, blood is going to come into the right atrium first. So I'm going to draw these vessels in blue, just because they're coming back to the actual heart, and we had drawn veins in blue before. Okay? So we have actual blood that's coming from the person's body, and it's making its way to the actual heart. Okay? So this is your inferior and your superior vena cava that's dumping blood into the heart. And it dumps it into the right atrium. Okay, so this actual chamber is quite small. It's lined with muscle. And what it's going to do, this actual chamber is in charge of sending blood not very far, just straight down into a much larger chamber. And that larger chamber is the right ventricle. So when blood actually enters into the atrium, it's continuously flowing into the atrium, and large amounts of it are being dumped into the atrium, and that hollow space is being filled rather quickly. So as soon as blood dumps in, a little valve up at the top here shuts off. It closes so that the actual pressure can build inside the atrium, and that right atrium is going to contract or constrict. The muscles are going to squeeze. And what it's going to do is, it's kind of like that rubber ducky. When you squeeze the rubber ducky, the water goes shooting out of the bottom or through the mouth or wherever the opening is. The same thing happens in the heart. So that contraction of that muscle is going to force open a little valve here that's very important. This is the first of the 2 main valves that separate the atria and the ventricles. And on the right side of the body, we call this the tricuspid. Okay, and I'm actually going to write that somewhere else. Tricuspid is so named because this valve is a little bit different from the other ones we've seen so far in that it has 3 flaps. It has 3 flaps that divide, they open up, and then they flap closed over one another. So if the vessel is circular, okay, it's kind of like 3 little thirds. And they all open up, and that blood gets dumped into the actual right ventricle. Okay, so this blood goes into this other chamber right here, known as your right ventricle. So this is your right atrium, and this is your right ventricle. Okay? Now, the ventricles are much larger openings than the atria. They also have a little bit more muscle around them. And this is important because they're in charge. The atria are only in charge of going from one side of the heart to the other. The ventricles have to be a little bit more muscled because they're in charge of sending the blood away. So that has to have a little bit more force behind it. And what actually happens here is the ventricle has one little opening, and that opening down here is going to make its way to the actual lungs. Now, what are the valves that actually go to the lungs called again? What are valves that go away from the heart? Or vessels, sorry. Vessels that go to the heart are veins. What are vessels that go away from the heart? Arteries. So I'm going to draw this in red just because I've been drawing all my arteries in red. But wait till we actually start putting colored red blood cells in there. Because is the right side of the heart oxygen rich or oxygen poor? It's oxygen poor. Even though this is an actual artery, okay, it's oxygen poor. And I'm going to draw my actual lungs up here. Okay, so I've got my trachea, my bronchi, and I've got my lungs. Okay, so this, the actual artery that leaves the right ventricle is called the pulmonary artery. And that's because it's going straight to the lungs. It is bringing deoxygenated blood to the lungs. So we're actually going to draw the red blood cells here as being blue because they're oxygen poor and carbon dioxide rich. So when they get to the lungs, gas exchange occurs, and then we end up having another vessel that brings this oxygen-rich blood back to the heart. What kind of vessel brings blood to the heart? An artery. Or sorry, a vein. So the veins are actually, we're going to draw them in blue here. These guys are coming back to the actual heart. Okay, so if they're going from the lungs to the heart, these are actually going to be called pulmonary veins. Okay, and look at this. Gas exchange has occurred, so now our red blood cells are full of oxygen again. And they're going to dump into the left side of the heart. So we have our left atrium. And again, we have another little valve here. This one is going to be called the bicuspid. How many flaps do you think that has? 2 flaps, exactly. So it's just divided in 2. Okay, and from the bicuspid, that blood then goes into what we call your left ventricle. Now, I want you to look at this image, and yes, it's a crude drawing. But what do you notice between the actual left ventricle and the right ventricle? If we look at both ventricles, we'll see that the left ventricle has a much thicker amount of muscles surrounding it. The two chambers in reality are roughly the same size, but the reason that the left ventricle is thicker is that it has to provide a much more powerful contraction or a pulse or a push than the right side does. Because where is this blood going to go? It's going to go to the body. So it's got a larger distance to travel. It's longer to get to the bottom of your baby toe than it is to go from your heart to your lungs. Your heart and your lungs are right next to one another. The rest of the body is a lot further away. So that extra muscle is there to provide a more powerful contraction. And that blood is then going to go to the rest of the body. And it's going to leave through the major blood vessel, okay, which then branches off. And that is called the aorta. So it's going to bring a bunch of red blood cells. And this is your aorta. Okay, to the body. That's going to get into the little capillaries. I'm going to draw these by little lines in the body everywhere. Okay, which are then going to, at the end of the day, dump into much larger blood vessels, which dump into your superior and your inferior vena cava, which then go back into the heart. So this is a convoluted drawing, but do you see the double circulation here? Heart to lungs, lungs to heart. That loop is called pulmonary circulation. That is your pulmonary circulatory system. Okay? Whereas when we go heart to body, body to heart, that is the circulatory system that feeds the entire system as a whole. Okay? The system of all of the different organs, all of the different tissues, all of the different cells. So we call that larger system the systemic. So we know that our four-chambered heart is really good at dividing oxygen-rich and oxygen-poor blood. And the fact that we've got a four-chambered heart makes it so that we have this dual circulatory system. Because at any one time, blood is being dumped both into the right and left atria. They fill up, they both contract together. That blood goes through the tricuspid and the bicuspid into the right and the left ventricles at the same time. They both contract, which is why we often hear when somebody actually mimics a heartbeat, we hear that dump dump. Okay, that double contraction, one right after the other. And that's because your atria contracts, followed very quickly by your ventricles contracting. And this is continuous. All right? They both have different destinations. They both have different pressures. They both utilize the two main types of blood vessels, which is why I wanted to draw the actual color of the blood cells. The blood cells denote whether the blood is oxygen-rich or carbon dioxide-rich. Okay? Not the actual color of the vessel. We colored veins in blue. We colored arteries in red.